6.1, day 1. Chapter 6 is going to be pretty short because, I mean, we're done with new material before next Friday, right? Then we have Christmas break, and we won't be learning anything new when we get back. So chapter 6 is going to have to deal with exponents. We're going to learn some different properties of exponents. We're going to learn about graphing with exponents and things like that. Again, before I start, anyone else want to turn on their camera so it's not just the 3 of us? Oh, the 4 of us now again, because Nick came back. Nobody? Aaron? No. Corey? No. Asia? No. Nobody? You guys, I guess Hayden, Nick, and Kason just, at least I know you guys kind of like me, right? Maybe a little. You look scary in the morning. Don't we all though? Like, I feel like we're all probably, what? You're saving us. You're saving us from the site. Well, then you better keep that camera on, bud. I'm gonna stare and be like, Nick's eyes open. Like, it's hard to tell with the glasses anyway, so that's just not good for you. I can't say I haven't done it though. All right, well then let's get through this fast, right? So that Nick can go take a nap before his next class. All right, so what is an exponent? What does it mean? So if I tell you guys to take 2 to the 5th, does anyone know what that means? Like, does anyone know what you're actually doing? Nick? Exactly, right? Like if something's squared, you're multiplying it by itself twice. If I'm taking 2 to the 5th, I'm multiplying 2 times itself 5 times. That's exactly what this is. So it's 2 times 2 times 2 times 2 times 2. That's what that means. Now, if you have a handy dandy calculator, I highly recommend getting it out. Or you can always use your phone calculator, or there is a calculator on your device. But there are a few different ways to plug exponents into your calculators. First of all, it could just do 2 times itself 5 times. Another way to do it is if you look at the left-hand side of your calculator, there's this little up arrow button, right? It kind of looks like the top part of a triangle. It's right under the pi symbol. Looks like that. That's how you can do an exponent in your calculator. So you could do 2, and then your little, like what's called a caret button technically. Okay, it'll look like this. And then you can put your 5, and 2 to the 5th, or 2 times itself 5 times would be 32. Okay, so Nick told us what 2 to the 5th means. Somebody else, what's 4 to the 3rd mean then? Exactly, it means 4 times 4 times 4. And again, you could do 4 times 4 times 4 in your calculators, or you click 4, and then you use your little up arrow or your caret button, and then put your exponent of 3. So it looks something. Can you guys see that? I know it's probably backwards because of the camera, but imagine it's not backwards, and that's what it should look like. So that would be. It's not. Okay, kind of like in my little screen here, it looks backwards. I wasn't sure what it looked like for you guys. Okay, so that would be 64. Okay, well now, what if this is a variable? Remember, this is called a base, right? Is there really any different? Oh, hi, Alex. Is there really any difference? What do you guys think if 4 to the 3rd means 4 times itself 3 times, and 2 to the 5th means 2 times itself 5 times? What do you think x to the 8 means? X times itself 8 times. Now here's the thing though, it's just an x, right? You can't, there's no number there. So all we're going to write here is just to realize this means 1, 2, 3, 4, 5, 6, 7, 8 x's. That's just what that means. It means you have 8 x's being multiplied. 3 to the 1, well, what do you think 3 to the 1 then means? If you have an exponent of 1, how many 3's are you going to have? Yeah, it's just one of them, right? It's just 3, right? I mean, because there's no other, if it was a 3 to the second, it'd be 3 times 3. If it's just 3 to the first, then that means that's just saying there's 1 3. Okay, so if I have 2 to the fifth, that means I have 2, or I'm sorry, I have 2 5 times. If I have 4 to the third, I have 3 4s. If I have x to the eighth, I have 8 x's. If I have 3 to the 1, that means I just have a 3. So what I want you guys to do is keep these things in mind, and we're going to talk, or we're going to review combining like terms. Remember, that's just when you add or subtract things that look the same, like x's go with x's, y's go with y's. And then we're going to talk about a few of our exponent rules today. So what happens when we add or subtract things with the same exponent? Remember, to combine your like terms, you need the same exponent, the same variable and the same exponent. So if you look here, we have a 3x and a 5x. They both have x's on them, right? And I don't see any little exponents, so these are good. It's just an x term and another x term. So can someone remind us, what would 3x plus 5x be if we added those together? Yeah, Hannah says 8x. I agree. That would absolutely be 8x. You just add the numbers on the front. All right, if you had 4y to the fifth and 2y to the fifth, if you take a look at these, I have y's, and they both have the same exponent, right? They both have the 5. So that means they're like terms, so they can be combined. So all you really got to think about is the 4 minus 2 part. Isn't 4 minus 2 just 2? So if I take 4 minus 2, that's just going to be 2. And then I just bring my y to the fifth with me. Nothing with that changes when you add or subtract. You just add or subtract the number in the front, really. Well, what about something like x to the third plus x? Are those like terms? If they don't have the same exponent, are they like terms? No, they have to have the same exponent. So I actually can't add these. I can't do anything with them. So we'll just say can't be simplified. I can't do anything with them. They're not like terms. However, while I can't add or subtract them, I am allowed to multiply or divide them. Okay, and that's what we're going to learn about today, is rules that happen when you multiply or divide things with exponents. All we've done so far is add or subtract, right? We add or subtract, add or subtract, add or subtract. Today we're basically going to learn like how to multiply and divide them. And that's just going to be some different rules. So today we're going to learn 3 of our rules. We're going to learn the product rule. Product means multiply. We're going to learn the quotient rule, which is divide, and then power to a power. So that's like you're going to have some parentheses in there, and I'm going to teach you what that means. So in this table, we're going to look at what our rule looks like, a little explanation, and then look at some examples. And then really we just do some examples on the back, and then we'll be done. And we might even skip around a little. All right, so product rule. How your product rule works is if you have x to the a times x to the b, and a and b, guys, are just numbers, 2 and 3, 5 and 7, 4 and 6, doesn't matter. Then what you do is you are going to add your exponents. So if I have to take x to the a times x to the b, first of all, x's go with x's, so I'm allowed to combine those. And our rule is it's going to become x to the a plus b. So what I do is I take my 2 exponents here, and they're going to get added together. So I have to take my exponents and add them together. So my rule, if I'm multiplying, is to multiply powers with the same base. And when I say the same base, I mean they're both x's, they're both y's, they're both z's, they're both whatever. Then you add their exponents. And there's like a cute little way to remember it, and I'm not much into like little cutesy ways of remembering things, but occasionally I'll throw them at you guys to help you out. The little like cutesy way to remember this is birds of a feather add together. I didn't make it up. It's just a little rhyme to help you remember it. Okay. So birds of a feather add together. So here, if I have x and x, x and x, do you guys see an exponent on either of these? Like a little number up at the top? We can't physically see one, right? If you can't physically see one, does anyone know what's technically there? It's just invisible. Anyone? Yeah, it would be a 1, exactly. So technically this is x to the first times x to the first. So our rule is to add our exponents. Well, ladies and gentlemen, what's 1 plus 1? 2. So if I have x times x, it becomes x to the second, because 1 plus 1 is 2. So I just take my exponents, which were 1s, and I add them together to get 2. So if you take a look at this next one, I have x squared times x to the third. Well, what's 2 plus 3? 5. So this will be x to the fifth, but let me show you why this works the way it does. I promise you that I'm not just like inventing stuff and pulling it out of thin air. What we talked about above is if you have an exponent, like if you have 2 to the third, that means you have 2 times 2 times 2. Well, if I have x squared, this technically means, here, I'll color code this for you. This technically means that I have x times x, doesn't it? And if I have x to the third, this technically means I have x times x times x. Well, if I write them all out like that, how many x's do I have altogether? Okay, Asia. Take a look. How many I have? Sorry, what was that, Hayden? Yeah, I have 5. And what's 2 plus 3? 5. Not a coincidence, right? So if I write them all out, I end up with 5 x's. So if I combine these, I am going to have x to the fifth, because 2 plus 3 is 5. Okay, so you're just adding them. Again, because if you wrote them all out, that's how many you would have. So then we have our quotient rule. Quotient, just a fancy word for divide. So here, to divide powers with the same base, so both x's, both y's, both z's, or whatever they are, then what you do is subtract their exponents. Sorry, that glitched there. That should be a t. So you subtract their exponents. Our little cute way to remember this is stack them and subtract them. Because if you have division, doesn't it kind of look like one thing is stacked on top of the other? Right? So they're stacked on top of each other, so you subtract them. So here with your x's, we have an exponent of a and an exponent of b, again, whatever the numbers are. And your rule is to take those two numbers and subtract them. So your new thing would be x to the a minus b, whatever a minus b is. All right, so let me show you why this works the way it does. It's very similar to how this works here. If you take a look at the top of your fraction, I have x to the third. So that means I have how many x's on top? Anybody? If I have x to the third, how many x's do I have? 3, exactly. So on the top of my fraction, I technically have 1, 2, 3 x's, right? Okay. On the bottom, I have x to the second. So how many x's should I draw on the bottom? Nick says 2. Yep, 2. All right. So I technically, this means I have 3 x's on top, 2 x's on the bottom. Well, think about like if you have something like a fraction where it's something over itself, like 5 over 5, isn't 5 over 5 just 1? Or like 2 over 2 is just 1. So if you have x over x, it's technically just 1. So like anywhere you see an x on top and bottom and it matches, you can cancel it. So what I mean by that is here I have an x, so I can take 1x on top and cancel it with an x on bottom. I have another x on top, so I can cancel it with a x on the bottom. And then if you take a look, aren't I just left with a single x? Just an x, that's all. That's all that's left. So that's actually my answer. If I simplify this, it's just x. Now, I'm not saying you have to go through and like draw all these x's every single time, but ladies and gentlemen, what's 3 minus 2? 1. And wasn't I left with just 1x? Yeah, so that's actually like how that works. You don't have to do this every time. I'm just showing you like why it would technically be x or x to the first, and you can write it either way. So here I have an x on top, and then technically I have x to the fourth on the bottom. So this means I have an x on top and 1, 2, 3, 4 x's on the bottom. So now think about what would cancel out here. I got an x on top, and that can cancel with an x on the bottom. But after that, is there anything else that's going to cancel? Do you guys see anything on top and bottom that'll cancel anymore? No, I don't see anything. Okay, so there's nothing left on top of this fraction. So there's nothing left there. So technically, I'm just going to put a 1 as like a little placeholder. There's nothing there. My x is canceled. It canceled out to be 1. But how many x's do I have left on the bottom? 3. So that means I technically have x to the third left on the bottom. Well, I want to show you guys something. If you take a look at this, on the top, I had just an x, right? Which is the same thing as x to the first. And on the bottom, I had an x to the fourth. Ladies and gentlemen, what's 4 minus 1? 3. And didn't I end up with an x to the third on the bottom? Yeah. Now, if you notice, I want to take a look at the difference between these two things. This first one, and if you're confused, that's okay. This takes a little practice sometimes. If you look at this first one, didn't you have a bigger number on top and a smaller number on the bottom? Yeah. Okay, bigger number on top, smaller number on the bottom. So we did 3 minus 2. Well, in the second one, didn't you have a smaller number on the top and a bigger number on the bottom? So we did 4 minus 1, but then didn't all our x's end up on the bottom of our fraction? That's because that's where we had more x's at. Okay, so we'll take a look at more like that in just a second, but I just want to show you when you subtract, you always want to do the bigger number minus the smaller number because we don't want to have negative numbers in our exponents. We'll learn about those on Thursday. All right, and then our last rule for today, and then we're just going to be practicing them, is power to a power. Power to a power is going to look like this. You're going to have your variable with your exponent in parentheses, and then you're going to have another exponent up at the top. And here, to find the power of a power, you multiply the exponents. So here, your exponents again. Oh, sorry, didn't mean to like scribble that out. I meant to go to the highlighter. So your exponents here again are a and b. So what we're going to do is our new value is going to become x to the a times b. We're going to multiply them together. Okay. And our rule with that, our little like cute way to remember it, is raise them high and multiply. And a way to kind of think about, like, you're raising them high because don't you have double exponents? So like you had one exponent and there's another exponent on top of it, so you're raising it high. So here you have x squared to the third. All right, so what's 2 times 3? 6. So according to our rule, this should become x to the 6th. Well, let me show you why it works though. If I have a third exponent, doesn't that mean I have something 3 times? Okay, so that means I should technically have an x squared, and an x squared 3 times, right? Okay, well from there, if I have x squared, how many x's do I have? 2. So this x squared here, this first one, that technically represents 2 x's. This second x squared technically represents 2 x's. And this third x squared technically also represents 2 x's. And count them out, how many did I end up with total? 6. And that's why it becomes x to the 6th. Again, you're not going to have to write it out. I'm just showing you why it works. So here, I'm not going to make us write out all these x's for this because that would be a lot of x's. But just apply your rule. Who can tell me what I would do with these two numbers here? Any ideas what I would do with the 4 and the 5? You could, but that takes a really long time. Here, we're just going to use our quick rule to find the power of a power u, multiply the exponents. Yeah, so all we're going to do is just, yeah, we're just going to take 4 times 5, which is 20, and you would get x to the 20. Okay, so again, we got our 3 rules. First rule, if you're multiplying, add your exponents. Dividing, subtract your exponents. Power to a power, multiply your exponents. So really, all we're going to be deciding is, are we adding, subtracting, or multiplying? Okay, so we're going to take a look at some practice here. We're going to practice just the product rule, then just the quotient rule, and then just power to a power. And if we have time, we'll get to some ones that are mixed up, but we'll see. All right, so we're going to first practice the product rule. So remember the product rule, product is multiplying, so you add your exponents. So maybe make a note to yourself here. We are going to add the exponents. So here I have x to the 9 times x to the 5. So my exponents here are 9 and 5. My rule is to add them. So, no, what were you going to say, Alex? Did you have an idea? Oh, okay, you were thinking multiply still? And you'll do that one when you see parentheses. Yeah, so this one we're adding, so what's 9 plus 5? Oh, come on, guys, we can add. What's 9 plus 5? I'm more asking because I want to make sure we're paying attention. Yeah, 14. So 9 plus 5 is 14, so this is going to become x to the 14. And that's it. You're done with that one. That's all it takes. Okay, so let's take a look at number 2. I have x squared and x to the, I'm confused. I don't see an exponent. What's technically there? Yeah. Yep. Yeah, it would be x to the third. Good, Alex. Yep, 2 plus 1 is 3, so that would be x to the third. Precisely. All right. Now take a look at number 3. Number 3 is a little different. Number 3, we also got some numbers in the front, right? Now think about what we used to do when we would combine our like terms. Wouldn't we just add or subtract our numbers in the front? Well, here we just have numbers in the front again. And isn't there a multiplication sign? So you're going to multiply your numbers with your numbers and your x's with your x's. So, and if you, I sometimes color code these just to kind of help us out. So numbers go with numbers. So see there you have like this number is a base. It's a big number. It's not a little exponent up at the top, right? It's big. It's the same size as the x. So what we're going to do is 3 is going to go with the 2 because those are just regular old numbers. And then your variables go with your variables. Okay, so numbers with numbers, variables with variables. So what we do is you just treat your numbers like you would before, right? If we were adding or subtracting like terms, you would add or subtract your numbers in the front. So here we're multiplying our terms. So what's 3 times 2? 6. So 3 times 2 is 6. And then you look at your x's separately. If you have x to the third and x to the 7, what's negative 3 plus 7? You multiplied. We want to add or subtract. Or I mean, sorry, we want to add. Yeah. So what you would do is negative 3 plus 7 is just 4. And remember, we can always use our calculators, right? So negative 3 plus 7 is 4. So my new answer, my simplified answer, is 6 6x to the 4th. So again, numbers with numbers, letters with letters. And sometimes color coding helps a little bit. All right. Can I scroll back over to number 4? Okay. So number 4, same idea. I have both big numbers as well as x's. So numbers are going to go with numbers, and variables are going to go with variables. So when we simplify this, and I'll color code this a little bit. When we simplify this, what's 2 times 4? 8. And then if you have x to the third and x to the 7th, what's that going to give us all together? Yep, x to the 10. Right? So 2 times 4 is 8, and then 3 plus 7 is 10. And that would be our final answer, 8x to the 10. Do I have you guys so far? I'm really only hearing from the same 3 people. Jake, Aaron, Corey, Jesse, Mason, Brooklyn, Kason, do you guys have any questions? No? No. Hannah, you good? I don't think I heard from you. Lynn, I think you just joined. Olivia, we're good? Okay. No, we're not good, or no, we don't have questions? Okay, no questions. Okay, cool. All right. So now let's take a look at 5. Somebody tell me what's different about number 5. It has x and y. So does anyone think they know what might happen with something like this? Who's going to go with who? Nick says absolutely not. There's too much happening here. Well, think about when you used to add and subtract like terms, right? Didn't x's go with x's? Didn't y's go with y's? Same thing's going to happen here. X's go with x's. Y's are going to go with y's. So what we're going to have is and actually I'll grab a different color for y's. So x's stay with x's, and then y's stay with y's. Can you guys still see that okay with the highlighting over it? Okay, cool. I probably have an answer, hopefully. Mm-hmm. Yeah, they are two different variables. Is that? Oh, you mean like how there's like no like symbol in between them? You're right. There is technically no symbol in between them. And something to remember is when you have two things that are next to each other like that and there's nothing in between them, technically it's multiplication. So like if you have like trying to think of a good example. Oh, like if we have like 3x, technically that means 3 times x. So if you don't see something there, it's technically multiplication. So this could be rewritten. I don't know why that keeps turning off. This could be rewritten like this, Nick. That means the exact same thing. It's just written differently. Does that help? Does that answer your question? And I wouldn't even stress about that. Just think x's with x's, y's with y's. I see a multiplication sign, so everybody's being multiplied. So I need to fix my colors here. Okay, so x's with x's. I see an x squared, and then what's this x? I don't see an exponent on him, so what does he mean? Okay, Hannah says 1, I agree. Okay, so if I have x squared and x to the first, how many x's am I going to have, ladies and gentlemen? Come on, guys. If I have x squared and x to the first. 3. I'm going to have x squared and x to the first is going to make x to the third. Exactly. Okay, now what I do is I look at my y's. So now take a look at your y's, and I have y to the third and y to the fifth, which all together will give me y to the what? 8. Exactly. And I'm done. That's it. I combine my y's. I combine my x's. I combine my y's, and I'm done. It's one that kind of looks a little trickier than it is, right? Keep things that look together, look like each other together. So x's with x's, y's with y's. Do we see where the 3 and the 8 came from? Okay. All right, so last one of these, take a look at 6. So 6, again, we're turning it up one little level. This time we have whole numbers, x's and y's. So same idea. Big numbers in the front, go with big numbers in the front. So the 3 goes with the 7. X's go with x's. Well, I see an x here, but do you guys see another x? So is there going to be anybody to combine him with? No. Okay. And then y's will go with y's. So let's take a look. So just combine. This is why I color code this. Combine what goes together. Ladies and gentlemen, what is 3 times 7? Come on, guys. Show me we're paying attention. What's 3 times 7? 21. Do we understand why I took 3 times 7? Because I have a 3, right? A whole number 3 times 7 right here. Now I have my x to the 5th. Is there anybody he can combine with? Are there any other x terms for him? No. So what do you guys think I'll have to do? Can I do anything to it? No. So I'm just going to bring it along as part of my answer. I can't do anything with it. And then I have y squared and y to the 4th. What's y squared times y to the 4th going to be? What's my rule? What do I do with my exponents? Yep, I add them. So I'll have y to the what? 6. So I did my 3 times 7 is 21. X to the 5th had nobody to combine with, so I just brought them with me. And then y squared times y to the 4th is y to the 6th. Because my rule is to add. And that's my final answer. Okay. So again, we're just going to practice our rules, and then if we get the chance at the end, we'll try to look at a few that are combined. But we spend a couple days on this, and we'll practice this tomorrow during our 8-block day. So it'll be like a little practice thing for it. Okay, so let's practice our quotient rule. So let's go back to the front and let's see. So our quotient rule, to divide powers with the same base, you subtract their exponents. So here, don't all these have division bars in them? You guys see how they're all fractions? Everybody here is a fraction, so we are going to use our quotient rule. And our quotient rule says to subtract the exponents. So let's take a look at number 1. I see an exponent of 7 and an exponent of 4. Now, when you subtract your exponents, you always want to look and see where your bigger exponent is, because it's where you have more x's, right? Because that's where you want all your leftover x's to go. So here, if I have x to the 7th and x to the 4th, what I'm going to do is subtract my exponents. So what's 7 minus 4? 3. So I'm just going to end up with x to the 3rd. And I don't have to worry about my fraction anymore, because didn't I have more x's on top than I do on the bottom? So technically all my x's on the bottom cancel out, so I don't need my fraction anymore. You okay over there, Hayden? Yeah, I get it. I understand. Okay, so here, take a look at number 2. We have 4x to the 5th and 2x to the 3rd. So this one, it's a little different. We got our numbers in the front again, right? So same idea as before. Keep your whole numbers with your whole numbers and your x's with your x's. So numbers with numbers and x's with x's. So here we're dividing, right? So we just treat this like division. What is 4 divided by 2? 2. So that's going to become 2. And then x to the 5th divided by x to the 3rd, we use our rule, which says to subtract. And what is 5 minus 3? 2. So we will then have x to the 2nd. And our fraction is gone because everything on the bottom kind of canceled out with stuff on the top. We don't need it anymore. Now, if you take a look at number 3, what looks a little different about number 3? Good job, Nick. Yeah, the smaller exponent is on the top. So are we going to be able to get rid of our fraction for this one? No. Our fraction's going to have to stick around because our leftovers are going to go on the bottom here. Because when we do something like this, we don't want to take 3 minus 10. Because 3 minus 10 is negative 7. And you guys haven't learned it yet, but we don't want, well, you haven't learned your rule yet for negatives, but we don't want negatives in our answer, like negative exponents. They just don't work nicely. So instead, you always bring your smaller exponent to your bigger exponent. So think of it like you're taking your 3 and moving it down. So what's 10 minus 3? 7. And how this works is we are going to have x to the 7th on the bottom of our fraction, because again, 10 minus 3 is 7. Now, if I got rid of everything on the top, again, think about it like I moved it to the bottom. There's nobody left on the top, right? Well, does anyone know what number I could put there? Just kind of to hold its place and keep my fraction? Yeah, you would just do 1. Exactly. So let's look at that again with I'll just kind of write one off to the side here just to kind of get you guys in the habit of it. So if I had x to the 5th, sorry, that doesn't look like a nice 5. So this is just a little extra example here. If I had x to the 5th over x to the 8th, I have more on the bottom, right? So what's 8 minus 3? I'm sorry, what's 8 minus 5? It's 3. So this would become 1 over x to the 3rd, because that's where we want our leftovers to be. If I had x to the 2nd over x to the 5th, what's 5 minus 2? 3. So I would have 1 over x to the 3rd. If I had x to the 4th over x to the, I don't know, 8th, what's 8 minus 4? 4. So I would have 1 over x to the 4th. Are you guys kind of seeing that? Sometimes the repetition helps a little bit. Are we awake out there? A couple of us are. Are the rest of us awake? I'm not convinced. All right. So we are over here on number 4 now. Number 4, we got x's and y's. So again, keep your x's with your x's. Keep your y's with your y's. So x's go with x's. And y's go with y's. So take a look at the x. Is my bigger exponent on the top or the bottom? The top. So where am I going to put all my leftover x's? If that's where I have more, I want them on the top, right? Yeah, I want them on the top. So what is 8 minus 2? 6. Exactly. So I'm going to have x to the 6th, because 8 minus 2 is 6. And I don't need my fraction as of right now, because didn't the bottom of this part cancel out? It's gone. All right, now look at your y's. Do I have more y's on the top or the bottom? Top again. So I want to do 7 minus 6, and what's 7 minus 6? 1. So I'm going to have y to the 1. And again, everything on the bottom moved to the top, so I don't really need my fraction anymore, right? So I'm done. It's y to the 6th times y to the 1. All right, take a look at number 5. So I see x's and y's again. So again, x's go with x's, and y's go with, oh, wrong color, and y's go with y's. Aiden, did I just see that you joined? Maybe. Okay, so let's take a look at our x's. So x is first. Oops. Do I have more x's on the top or the bottom? Bottom. Yep, I have more x's on the bottom. So that's where I'm going to want my leftovers, right? So am I going to need to keep my fraction, or can I get rid of my fraction? I'm going to have to keep it because I need them on the bottom, right? And if they're on the bottom of something, I still have to have a fraction there. So if you take a look at just the x's, 8 minus 5 is 3. So that would be 1 over x to the 3rd, right? You don't have to put the 1 on top if you don't want to until you know you need it. It's totally up to you. Sometimes what I'll do with something like this is just put my fraction bar and then kind of see what ends up happening. So here, I have 8 minus 5, which is 3. So I'll have x to the third on the bottom. Now let's take a look at your y's. Do I have more y's on the top or the bottom? The top. So where do I want all my leftover y's to go? The top. And this, remember, this is technically a 1 here. So what's 3 minus 1? 2. So I should have a y to the second on the top, right? My x's, I had more on the bottom, so my x's are on the bottom. My y's, I had more on the top, so my y's are on the top. All right, and then do I have, one more of these kind. All right, so this time I have numbers, x's, and y's. So numbers go with numbers. So 9 goes with 3. Oh, sorry. X's go with x's, so x to the fourth and x. And then y's go with y's, so y to the sixth and y to the fourth. All right, so let's go through and look at all what goes together. Now again, on one like this, there's kind of a lot happening, isn't there? I'm not sure if I'm gonna need my fraction or not. So something that I would maybe recommend you guys doing is just go ahead and put a fraction bar, right? And see what happens. And if you don't need it anymore, you can always erase it at the end. So let's look at our numbers. We have 9 divided by 3. What's 9 divided by 3? 3. And isn't our bigger number on the top? So we're going to put a 3 at the top of our fraction because 9 divided by 3 is 3. All right, now let's look at our x's. I have x to the fourth over x. So do I have more on top or bottom? The top. So can someone tell me how I would simplify that? If I have x to the fourth over x, what's that going to become? X to the what? I have x to the fourth and then just x on the bottom. You're thinking adding. If we're doing the quotient, stack them and subtract them. So that's okay. Somebody, guys, don't let Hayden sit here and he's hanging. I trust that more than 3 people in this class can subtract. What do we think, ladies and gentlemen? Oh, I'm worried. Yeah, okay, so technically that is a 1. You're right, we can put that there if we want. Yeah, exactly. 4 minus 1 is 3. And I got more on top, so they're going to go on the top. All right, now let's take a look at our y's. I got y to the 6th over y to the 4th. So remember, stack them and subtract them. Somebody else who's in this class, let me know that we are conscious, that we have not passed out in front of our computers or whatever, or walked away. Nick, I know you know. You're with it. You're with it today, bud. Proud of you. What do we think? Y to the 6th, y to the 4th? All these people are saying they don't have questions. But now I'm asking y'all a question and we can't subtract. What do you think, Jake? It is 2. Well, y to the 2, right? Don't forget your y. Yeah, but we're going to subtract. It's y to the 2nd. And we have more on top, so it needs to go on the top. So take a look. Isn't everybody on the top here? Yes or no? Is everyone on the top of my fraction? Yes. So if everybody's on the top of my fraction, do I really need my fraction bar? No, not really. So I'm just gonna kind of get rid of him because I don't really need him. And that's it. I'm done. 3, x to the third, y to the second. All right. Last one. Power to a power rule. So if you go back up to the top of your notes, power to a power, to find the power of a power, you multiply the exponents. This is raise them high and multiply. So we are going to multiply our exponents. So here we have x to the fourth squared. So raise them high because you have an exponent to an exponent and multiply. 4 times 2 is 8. Good job. So it would be x to the 8. And that's it. You're done with that one. Those ones should hopefully not cause us too many issues. Okay, so now we got x to the third, y to the fifth. Let's see who's awake here. Power to a power. Raise them high and multiply. Corey, what do you think is going to happen? What do we need to do? Hayden, I think, is that your music? Corey, what was that? Okay, so our rule here, raise them high and multiply, right? So what two numbers do I need to multiply, Corey? And what is 3 times 5? Yep, so this would become x to the 15. Okay, all right. So actually, before we go on to a harder one, I'm going to make sure we're all awake. So if I have x squared to the, how about the fifth? X squared to the fifth. Jesse, what's x squared to the fifth going to be? You there, Jesse? Raise them high and multiply. Oh dear. Brooklyn sent us something. Brooklyn says 10. Okay, good. That's what our exponent will be, right? Can anyone tell me the proper way I need to write my full answer, though? Yeah, it would be x to the 10, right? Okay. So let's see. Try this one more time. If I have x to the third squared, x to the third squared, raise them high and multiply. Hannah, what do you think that would become? Okay, that's fair. So here, Hannah, our rule is to multiply our exponents. So 3 times 2 is 6. So you just bring your variable with you, which is x, and then write your 6 to it. Does that clarify a little bit for you? Okay. All right. Let's see what else we got. How about x to the fourth and then to the third? So x to the fourth to the third, x to the fourth to the third. Lynn. Oh no, that's not good. No, we're just at this point living in a world where it's almost unavoidable at some point. So, number 3. There you go. All right, number 3. Here we got a base of 3, so we got a whole number, and we got a variable that's x. So we got 3, x to the fifth, and then we're squaring it. So here we technically have 2 things in our parentheses that need to get squared. We need to square our 3, and we also need to square our x. Okay, so if you wanted to, you could almost rewrite this as 3 squared and x to the 5th squared. It's basically what it means. Okay, I got to square both of them. So just in general, 3 is a regular old number, so we can square it. What's 3 squared? Remember, 3 squared is like 3 times 3. 9. And then here I have x to the 5th squared. So remember, raise them high and multiply. X to the 5th squared would become what? Good, Olivia. X to the 10. Good. So it'd be 9x to the 10. Square your 3, square your x to the 5th. All right, let's take a look at number 4. Number 4, we got x's and y's. So x and y. So you have x and then y to the 3rd, and the whole thing is squared. So we got to square our x as well as our x to the 3rd. Now, our y to the 3rd, sorry. Now, do you guys see an exponent on this x? No. So what's technically the exponent if we can't see it? 1. Okay, so that's x to the 1st. So remember, raise them high and multiply. What's 1 times 2? Olivia says 2. Exactly. So what this is going to become is I have x to the 1st squared. 1 times 2 is 2, so that's x squared. Then take a look at your y's. We have y to the 3rd squared. What's 3 times 2? Good, 6. So that would become y to the 6th. Right? Square your x, square your y to the 3rd. Do we see where the 2 and the 6 came from? Okay. All right, so now let's take a look at 5. So here we got x to the 5th, and we have a y to the 7th. So x to the 5th, y to the 7th. Raise them high and multiply. Someone tell me what they think our x term is going to become. X to the what? Good, Olivia. Olivia says x to the 15, because 5 times 3 is 15. Then take a look at your y's. We have y to the 7th to the 3rd. Somebody else, what's that going to become? 21. Y to the 21. Good. How do we feel about those two? I feel like when they just have letters, it's okay. Right? I feel like sometimes like putting those other numbers in there makes it a little tricky. Okay, so this is the last one. We're not going to have time for this bottom section today, but that's okay. So number 6, we got a 2. We have an x to the 4th, and we have a y to the 2nd. So now we got to cube all of these. We got a little exponent of 3 here. So we're going to take 2 to the 3rd, x to the 4th to the 3rd, and y squared to the 3rd. Now you can do this in 1 step or in 2 steps if you want. So if I have to take 2 to the 3rd, 2 to the 3rd, remember, isn't that just 2 times 2 times 2? Can someone tell me what 2 times 2 times 2 is? Again, we're doing our 2 to the 3rd. What's 2 times 2 times 2? 8. And then here we have x to the 4th to the 3rd. What's that going to become? X to the 4th to the 3rd. Yep, x to the 12. Good. And then we're going to look at the y's. We have y squared to the 3rd. That's going to become y to the what? Good. y to the 6th. All right. So we have 8x squared y to the 6th. Alrighty. So I don't think we're not going to have time to get to the bottom part. If we have time, we'll look at that another day. That's just like looking at multiple rules at once. Okay. But I think we're pretty cashed out for today. So